Hello, my dear children. Today we are going to discuss the concepts or points in exercise 5.2, derivatives of composite functions. This is very important concept, very important point. Derivative of a composite function. This is also called chain rule. This is also called chain rule. Let f be a real valued function. Let us consider f is a real valued function which is a composite of two functions u and v. Here f is a composite functions of u and v. That is f is equal to v circle u. In the functions chapter you have studied composition of two functions. Here also f is a composition of these two functions. Suppose t is equal to u of x. T is a function in the x, in the variable x, and if both dt by dx and dv by dtx exist, if both derivatives exist, we have df by dx. df by dx is equal to dv by dt into dt by dx. This is called chain rule. Otherwise, f circle g whole dash of x, composition of two functions f and g, is equal to f dash of g of x into g dash of x, where f of x and g of x are differentiable functions. We frequently use this concept, the derivative of a composite function. Let us take an example to understand this concept very clearly. Okay, my dear children? Right. See, let us take this example. Find the derivative of the function given by f of x is equal to sine of x square. Okay, my dear children, we have to find the derivative of this function. This is a composite function of sine function and x square function. Okay, my dear children, sine function and x square function. This is a composite of the two functions. So let us consider given function y is equal to f of x. Y is equal to f of x. This implies y is equal to, what is f of x here? Sine of x square. I wrote f of x in RHS, sine of x square. Now differentiate with respect to x. We differentiating the functions on both sides with respect to x. In short form, we write like this: d dot w dot r dot t dot x. This stands for the full form, differentiating with respect to x. Okay, my dear children. In future, in general, we use this short form, differentiating with respect to x. Okay, my dear children. So here on both sides we are taking differential operator. I told you clearly in the previous classes, the differential operator is d by dx, because we are differentiating the functions with respect to x. So d by dx, this d by dx is a differential operator. What is this d by dx called? Differential operator. Okay, my dear children, right. On both sides we are writing the differential operator. Now here in LHS we get dy by dx, d by dx of y, d by dx of y, we get dy by dx. Now come to RHS. What is that first function? Sine function. I told you, sine function and x square function, the composite of these two functions. So we have to take this first function, sine function. What is the d by dx of sine x? Cos x. So consider this remaining part as x in your mind, that x square consider as capital X in your mind. So cos x, cos, what is x here in your mind? You assume capital X. So sin derivative is cos. So cos of x square into d by dx of x square. Now we have to differentiate the function x square. We have taken the derivative of this sine function. So sine derivative is cos. So cos of this function I wrote as it is into d by dx of x square. Understood this step, my dear children? Because d by dx of sin x is equal to cos x. d by dx of sin x is equal to cos x. So I wrote this step. Understood this step, my dear children? Right. This is equal to cos of x square into here d by dx of x square. It is in the form of d by dx of x power n. What is the formula? D by dx of x power n. N into x power n minus 1. So here n means 2. 2 into x power 2 minus 1. Because d by dx of x power n. D by dx of x power n is equal to n into x power n minus 1. Understood this step, my dear children? Here I wrote this function as it is cos of x square, and I am finding the derivative of this function x square. This is in the form of x power n. So d by dx of x power n, you know the standard derivatives, the derivatives of some standard functions. So d by dx of x power n is equal to n into x power n minus 1. In this case n is equal to 2. So 2 into x power 2 minus 1. In this formula I substituted. Is it clear, my dear children? That is equal to. Here 2 is a numerical coefficient. In general we write numerical coefficient at the beginning of the term. So 2 into cos of x square into x power 2 minus 1. What do you get? 2 power x power 2 minus 1. 1 only, x power 1. This is equal to 2x into cos of x square. This is the derivative of the given function. Understood, my dear children? Right. So this is the derivative of the given function 2x into cos of x square. Understood, my dear children? Right. Now come to the exercise 5.2 sums, my dear children. Page number 166. Page number 166. Question number 1. Question number 1. Differentiate sin of x square plus 5 with respect to x. Here we have to find the derivative of sin of x square plus 5. So let us assume that given function is y. So y is equal to sin of x square plus 5. Okay, my dear children? Differentiating with respect to x on both sides. Then we write the differential operator on both sides. What is the differential operator here? D by dx. Because we are differentiating the functions with respect to x on both sides. That is why d by dx is the differential operator. So I wrote the differential operator on both sides. Is it clear, my dear children? Right. Now here we get d by dx of y. We get dy by dx of y. What do you get? dy by dx. Now come to RHS. d by dx of sin of x square plus 5. What is the function here? Sin function, and x square plus 5 is another function. So first we find derivative of sin. We assume this entire part as x in your mind. So d by dx of sin x. What is the formula? D by dx of sin x? Cos x. So cos x means here x square plus 5 only, not x. Remember this point, my dear children. Into d by dx of x square plus 5. We have to find the derivative of this function. Whatever you assumed as x in your mind, you have to find the derivative of the function. Understood this step, my dear children? Right. This is equal to, so here I am writing d by dx of, because d by dx of sin x is equal to cos x. We are using this formula. Okay, my children, this is equal to cos of x square plus 5 into, here we have to find the derivative of this function. So d by dx of x square, d by dx of x square plus d by dx of 5. We can find derivatives of these two terms separately. Understood this step, my dear children? Right. This is equal to cos of x square plus 5 into, what is the d by dx of x square? It is in the form of d by dx of x power n. So its derivative is 2x plus, it is a constant function. D by dx of constant function is 0. Okay, my dear children. So because d by dx of x power n, d by dx of x power n is equal to n into x power n minus 1, and d by dx of constant, d by dx of constant, whatever the constant it is, its derivative is 0. Understood this step, my dear children? Right. Now here we get cos of x square plus 5, cos of x square plus 5 into, in this brackets, what you get here? 2x, 2x plus 0. What you get here? 2x. So finally we can write 2x into cos of x square plus 5. This is the derivative of the given function. Understood, my dear children? Right. Now come to this question, my dear children. Question number 2. Differentiate cos of sin x with respect to x. We have to find the derivative of this function, cos of sin x. So come to the solution part. Let us consider y is equal to cos of sin x. Cos of sin x. Differentiating with respect to x. I said this sentence can be written in the short form like this: dw or tx. Now the differential operator is d by dx, because we are differentiating the functions with respect to x. That is why differential operator is d by dx. So we wrote d by dx on both sides. Then what will you get here? dy by dx in LHS. In LHS we get dy by dx, and come to RHS. It is in the form of d by dx of cos x. It is a function of cos x and sin x composite functions. So d by dx of cos x, what will you get? Sin x minus sin x. So minus, consider this entire function as x in your mind. So d by dx of cos x, what will you get? Minus sin x into d by dx of sin x into d by dx of this internal function. Understood this step, my dear children? Because d by dx of cos x, d by dx of cos x is equal to minus sin x. Understood this step, my dear children? Right. This is equal to minus sin of sin x into, this is the direct formula, d by dx of sin x. What is the formula? Cos x into cos x. Because d by dx of sin x, d by dx of sin x is equal to cos x. So finally we get minus cos x into sin of sin x, which is the required derivative of the given function. Understood, my dear children? Right. Now come to the question number 3. Question number 3. Differentiate sine of ax plus b. Differentiate sine of ax plus b with respect to x. We have to differentiate sine of ax plus b with respect to x. Understood, my dear children? Right. Let us consider the given function is y. So y is equal to sine of ax plus b. I wrote here y is equal to sine of ax plus b. Now differentiating with respect to x. Here we are differentiating the both functions on both sides with respect to x. Then what is the differential operator? D by dx. Previously I told you many times, if we are differentiating the functions with respect to x, then the differential operator is d by dx. So we are writing d by dx on both sides. D by dx is the differential operator. Then in LHS we get dy by dx. D by dx of y. What will you get here? Dy by dx in LHS. In RHS, see here, what is the function? Sine function and ax plus b function. This is a composite of the two functions, sine function and ax plus b. So what I said, first we have to consider this function, sine function, and inside function, imagine, just to consider, okay my dear children, as x. So d by dx of sin x, it is in the form of d by dx of sin x. What is the formula d by dx of sin x? Cos x. So cos of ax plus b into d by dx of ax plus b. Understood this step, my dear children? Because d by dx of sin x is equal to cos x. D by dx of sin x. Consider this inside function, inside the brackets, that function consider as x in your mind. So d by dx of sin x. What is the formula? D by dx of sin x is equal to cos x. So cos x means ax plus b, not x. Remember this point, my dear children. So cos x into whatever the function you considered as x in your mind, we have to differentiate with respect to x. So ax plus b is considered in your mind as x. So we are differentiating that function here. Understood this step, my dear children? Right. This is equal to cos of ax plus b. We write this part as it is. Now we have to differentiate this function. Here plus symbol is there. So we can differentiate the terms separately. So d by dx of ax plus d by dx of b. We are differentiating these two terms separately. Understood this step, my dear children? Right. This is equal to cos of ax plus b into, here a is numerical coefficient, a is not variable, a is a numerical coefficient. So we write it outside, a into d by dx of x plus here b. B is constant. B is a constant function. So d by dx of constant function is 0. Previously, in the previous question, we wrote d by dx of constant function is 0. Understood this step, my dear children? Right. This is equal to cos of ax plus b into a into d by dx of x 1. This is also derivative of a standard function. D by dx of x is equal to 1. I gave the list of the derivatives of some standard functions. In that list, this is also one formula. D by dx of x is equal to 1. So finally we get here a into cos of ax plus b. Here I am writing d by dx of x is equal to 1. D by dx of, because d by dx of x is equal to 1. Understood? My dear children, right.